Morning, class. We're going to start Unit 8, Day 2. And that's section 10.1. And our homework is page 1048, 29 through 37 odd, and 43 through 53 odd. And our topic today is summation notation. Okay, so if a sub n is equal to n squared, then the first 5 terms of the sequence is, well, we're going to have a sub 1, which will be 1 squared. A sub 2, when n is 2, 2 squared is 4. A sub n, when n is 3, you're going to get 3 squared, which is 9. A sub 4, 16. And a sub 5, 5 squared is 25. So that would give us the first 5 terms. So again, our first term is a sub 1, which is 1 squared. Second term, a sub 2, which is 2 squared. Third term, when n is 3, a sub 3, which is 3 squared. When n is 4, a sub 4 is 4 squared. And when n is 5, a sub 5 is equal to 5 squared. So that's kind of what we learned how to do on the first day of Unit 8. What if, though, we want to add the terms of this sequence? So what if we add the terms of the sequence? In other words, we have a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5. So in this case, we'd have 1 plus 4 plus 9 plus 16 plus 25. Let's see, 1 and 4 is 5, and 9, 14. 14 and 16 is 30. Is that right? And then 30 and 25. Wait, 1 and 4 is 5. 5 plus 9 is 14. 14 plus 16 is 30. And 30 plus 25 is 55. So the sum of the first 5 terms of this sequence would be 55. Now in math, we do use a symbol for summation. And remember, sum is to sum or to add things up. So we can use the summation notation. And the symbol we use is the capital Greek letter delta. And we can say, let's say, I equals 1 to 5. So our index is I. 1 is our lower limit. 5 is our upper limit. And then a sub I. So this symbol here This capital delta is our summation notation. So this tells us that we're going to sum these terms. So a sub I would be, you start at 1 and then you go to 5. So a sub I when I equals 1 to I equals 5. So it would be a1 and then you would just go in order 1, 2, 3 until you get to 5. 3, a4, a5. So the summation we described before would be written this way. Summation I equals 1 to 5 and then I squared. So I starts at 1. You're going to replace the I with 1 squared. Then when I is 2, 2 squared. So I goes 1, 2, 3, 4, 5 when I is 3. 3 squared plus 4 squared plus 5 squared. So there's our general term there. Summation. And then we would add those up. Okay. Now we don't always have to start at use the index of I. So let's take a look. A couple more examples. Okay. So let's take a look here. So we're going to do the summation. This time we're going to use, instead of I, k. So k equals 4 to 7. So here we didn't start our lower limit at 1. We started it at 4. And our rule this time is going to be negative 2 to the k and then minus 5. Alright, so that's going to be negative 2, k starts at 4, so to the 4th minus 5, plus negative 2 to the 5th minus 5, plus negative 2 to the 6th minus 5, plus negative 2 to the 7th minus 5. And then we're going to stop there because we started from k equals 4 to 5. Okay, so now when we evaluate these, well, negative 2 to the 4th is a positive 16. So here we're going to get 16 minus 5. Negative 2 to the 5th. Exponent is odd. Negative 2, so that would be negative 32 minus 5. 2 to the 6th is 64. Exponent is even, so it'll be positive 64 minus 5. And then 2 to the 7th is 128. Exponent is odd, so it'd be negative 128 minus 5. So our solution would be 16 minus 5 is 11. And then it would be plus negative 32 minus 5 is a negative 37, plus 64 minus 5 is 59, and then plus negative 128 minus 5 is a negative 133. So now when we add these up, let's see, 11 minus 37, so that would be a negative 26 plus 59, and that would be 59 minus 26, 33, and then minus 133. So our final solution would be negative 100. Okay. All right, let's take a look at another example. Okay, you might want to put a star next to this one. This one tends to confuse students. So here we're going to take the summation of a constant. So notice in this one, that this general term doesn't depend on the index I at all. But this is a summation. We're going to go from I equals 1 to 5. So you are going to have 5 terms here. So here, when I is 1, our term is 3. When I is 2, our term is 3. When I is 3, our term is 3. 4 and 5. So the answer here would be 15. So make no mistake, this is when I is 1, 2, 3, 4, 5. This is a 1, a 2, a 3, a 4, a 5. It's just that they're constant. But we're still going to take the sum. Okay. So this brings me to another caution. The domain of a sequence is the set of positive integers. Okay, so the domain of a sequence is the set of positive integers. Remember, 0 is not positive. So if you have a sequence, its domain is the set of positive integers, 1, 2, 3, 4, 5, etc. But that's not the case for a summation. Okay, so be a caution here. So for a summation, any integer can be used for the limits. Even negative integers and remember, 0 is also an integer. Okay. So any integer can be used for the limits. Positive, negative. So with that said, there are multiple ways that you could express the summation of a general term. Okay, multiple ways. So let's take a look at an example. Okay, so here we want the summation of the first 4 terms of I squared. So that's going to give us 1 squared plus 2 squared, 3 squared plus 4 squared. Okay, so that's 1, 2 squared is 4, 3 squared is 9, so 1, 4, 9, 16. So 1 plus 4 is 5, 5 plus 9 is 14, 14 plus 16 is 30. So that's the sum of the first 4 terms there. Okay, now take a look at this. So we're still going to do I squared, but instead of starting at 1, let's start at 0. Okay, so what I did here is we subtracted 1. So from our original, I equals 1. So subtract 1 for the lower limit. So we got to subtract 1 from the upper limit. And then we're going to do the opposite of here. So we're going to do plus 1. So we subtracted 1 with the limits. We added 1 there. Okay. When I is 0, when I equals 0, you're going to get 0 squared. Sorry, that should be like that. I plus 1 squared. When I is 0, you're going to get 0 plus 1 squared. Then when I equals 1, we're going to get 1 plus 1 squared. When I is 2, 2 plus 2, 2 plus 1 squared. And when I is 3, you get 3 plus 1 squared. Okay. So this becomes 0 plus 1, that's 1 squared. 1 plus 1, 2 squared. 2 plus 1, 3 squared. 3 plus 1, 4 squared. So now this becomes the exact same summation as we had before, and that's going to be 30. Okay, let's try it again. So this time, instead of starting at I equals 1, we start at I equals 2. So what I did here, from our original I equals 1, we added 1 to the lower limit, so we need to add 1 to the upper limit. So then that's going to go from 2 to 5. So here our I squared, because we added 1, we're going to need to subtract 1, I minus 1 squared. So now this becomes 2 minus 1 squared plus 3 minus 1 squared plus 4 minus 1 squared plus 5 minus 1 squared. Okay, so that gives us 1 squared, 3 minus 1 is 2 squared, 4 minus 1 is 3 squared, 5 minus 1 is 4 squared, which is exactly what we started here. So again, there's multiple representations of this original summation. So be aware of that. All right, so let's take a look at writing summations, or writing sums. In summation notation. So example, 1 cubed plus 2 cubed plus 3 cubed, and our last term is going to be 7 cubed. Okay. So the summation here, I starts at 1. Well, it's going to be I cubed. And our lower limit starts at 1, and we end at 7. So here's our lower limit 1, first term 1 cubed, upper limit 7, last term 7 cubed. And we're done. Let's try another one. 1 plus 1 over 3, 1 over 9, 1 over 27, plus 1 over 3 to the n minus 1. All right. So here, it looks like we're given a rule. So this is our rule right here. And this should be the rule for all of these terms. So if n starts at 1, then our first term should be 1 over 3 to the 1 minus 1, which is 1 over 3 to the 0. 3 to the 0 is 1. When n is 2, we should get 1 over 3 to the 2 minus 1, which is 1 over 3 to the first. We have that. So that's our rule there. So our summation notation would be I equals 1 to n of 1 over 3 to the I minus 1. So your last term, so we start when I is 1, at our last term, I is going to equal to n. So that's our solution there. All right, let's take a look at some properties of sums. Okay, so property 1, I equals 1 to n of c times a sub I. That's equal to, we can pull the, so c is a constant, so we can pull the constant on the outside, c times the summation I equals 1 to n of a sub I. So take a look at this example. Let's say we have the summation I equals 1 to 4 of 3i squared. So this would be 3 times 1 squared plus 3 times 2 squared, 3 times 3 squared, and then 3 times 4 squared. So you're not squaring the 3, the only thing you're squaring is the I. And if we were to rewrite this as 3 times summation I equals 1 to 4 of I squared, then what you're going to get here, so this is 3 times the parentheses of that, so this would be 3 times 1 squared plus 2 squared plus 3 squared plus 4 squared. And as you can see, if we distribute it, this 3 to all of those terms, it's going to directly equal what we had in the first term. So we were able to prove that the summation from I equals 1 to 4 of 3i squared is equal to 3 times the summation I equals 1 to 4 of I squared. So that's a property that our summations have. Okay, let's take a look at one more. Okay, so let's say we have a summation I equals 1 to n, so a sub I plus b sub I. Well, we can break these apart. So this is the same thing as the summation I equals 1 to n a sub I plus summation I equals 1 n of b sub I. Okay. So our example here, let's say we have summation I equal 1 to 4 of I plus I squared. So here you have two separate rules here. Well, when I is 1, you're going to get 1 plus 1 squared. When I is 2, 2 plus 2 squared, 3 plus 3 squared, plus 4 plus 4 squared. Now, when we break those apart, summation I equals 1 to 4 of I plus summation I equals 1 to 4 of I squared. Okay, so for the first one, here, summation from I equals 1 to 4 of I, we're going to get 1 plus 2 plus 3 plus 4 plus, now the summation I equals 1 to 4 of I squared, that's going to yield 1 squared plus 2 squared plus 3 squared plus 4 squared. Now, if we were to rearrange these using our commutative property, we could match up the 1 with the 1 squared, the 2 with the 2 squared, 3 with the 3 squared, 4 with the 4 squared. And it's going to be exactly what we have there. Okay. Alright, so our last one, won't go through the particulars of it, but with our commutative property, we know that 3 plus 5 is equal to 5 plus 3. But is 3 minus 5 the same thing as 5 minus 3? And the answer there is no. The summation I equals 1 to n of a sub I plus b sub I is equal to the summation a sub I plus the summation b sub I, also summation b sub I plus the summation a sub I. Okay, so that's true. It does follow commutative property. But the summation of a sub I minus b sub I is not equal to the summation b sub I minus a sub I. Okay, by the commutative property. Okay, ladies and gentlemen, that does it for assignment number 2, unit 8. All right? And we will have a quiz coming up. We will see you next time.